All right, so now the Toyota way, pillar, I guess we can call it number 2, and also adding in a little bit of dimming. The right process will produce the right results. Now they go on to say, redesign work processes so that nothing is sitting around. Problems will surface right away if we have even flow. Now right here is an example of even flow. One process number, or we'll call it A, produces, can do 100 per hour. B can do 100 per hour. C can be doing 100 per hour. So there's even flow throughout the system. One of my favorite days, and I got to make this short, I experienced true even flow. It's really hard to describe, but I had employees doing one thing, employees doing another thing, and me doing another thing. And as soon as they finished one thing, I would take it over to the next person and then get what they finished, and then I would go do my thing, come back, and all over again. So everything was moving, and it was a situation of even flow. It wasn't just one employee here, and then me. It was 2 employees here. It took 3 here, and then me. So we worked it out where we had the right people in the right places with the right techniques, and we had even flow. Until the problems will surface right away. Until I tripped on a step and almost broke my ankle, which was showing me that there was an obstacle there, a problem. And that disrupted even flow, because then they had to wait on me to kind of get back in order and do my thing. So when you have even flow, in this case 100 per hour, 100 per hour, 100 per hour, if anything goes wrong with, say, operation B, process B, then that's going to reflect. You'll see it immediately. That's what they're talking about. Use pull systems to avoid overproduction. Instead of just having a work schedule that we want to do, or the engineers want us to do, or the accountants want us to do so we can hit cost or create our own problems, here we use pull systems where customer demand drives the operation. If customer demand, maybe customer demand is only 80, so the operation slows down. Because we don't want to have inventory sitting around doing nothing. Now, another concept here is to go slow, build in quality, and then speed up to customer demand. I didn't just say speed up, I said speed up to customer demand. If we were to start out here and we were doing 80 and making a lot of mistakes, that would be a problem. But we want to build in quality. We start out, say, at 40, and everything is operating smoothly. Then we see if we can speed up with maintaining quality, and then we stop on, where we hit customer demand of 80. Here, again, there's no inventory. If the customers are driving the operation, as soon as the product hits the finish line of the operation, then it gets shipped to the customer where it gets consumed or used. We don't make too much. We don't make more than the customer can demands. Now, use stable, repeatable methods that equal consistency. Once we get a process ironed out and the process is producing the right results, the point here is we need to make things repeatable. We need to understand the processes and have consistency. Then we need to document what we're doing so everybody knows what to do. We know where we are, we have it documented, and we have a standard. So if everybody understands the standard, then we can improve, which Deming was saying the plan, do, study, act. We'll make a plan for improvement. We'll try it out on a small scale, study the results. If the results are good, if they're right, then we'll adopt and then start over for our continuous improvement baby steps. Now, leaving it like that, we don't really, I don't think we have a full understanding of what's going on. But they want stable, repeatable methods that equal consistency. Let's just go to the kitchen. You make spaghetti or whatever, and it's perfect. It's perfect, right? But we don't take time to write down how much oregano we put in there, what other spices we put in there, exactly how much salt. So there's never really a stable, repeatable method of making, say, spaghetti. It's just, we did this, and oh, it's great. And by the time we finish eating, go, we need to do this again, but we don't know how we did it. So we have to take notes, we need to document, and once we can document, we have that, everybody understands it, then we can improve. If we don't know what we're doing, we're just chasing our tails, right? And probably making things much worse. They also go on to say to question technology before adopting it. And most importantly, don't interrupt even flow. So a lot of technology sounds good. It sounds like it's really productive and our productivity is going to go up, but it interferes with even flow. I'll give you an example right here. If we were to take this process and add a robot to process number B, we have process number A that feeds into B, and B feeds into C. So if our process number 1 can do 100 an hour, and our robot, process B, can now, say, do a welding for 500 units per hour, and then process C can still only do 100, what would our output be? What would the output be for this series of processes? Well, first of all, process A would feed in 100 to the robot that can do 500 per hour. Is that going to help us at all? Well, not really, because it can only get 100 per hour. And then even if we waited 5 hours and then had them do 1 hour of 500 units, then they feed it to process C, which can only do 100. The result is still just 100. So now we've got a super fast robot that doesn't help anything. So when you look at all of this, we're getting organized. Our processes are organized. We're achieving even flow to serve customer demand. We know exactly what we're doing, and once we know exactly what we're doing, we can plan, do, study, act, and if the results are good, then we can adopt that, and now we have a new standard, a new process. So redesign work processes so nothing is sitting around. This is addressing muda. Muda is sitting around. Use pull systems to avoid overproduction. That's muda. That's addressing overproduction and inventory. Reducing inventory, I said no, but reducing it to a minimal amount. Muda, go slow building quality. If we go fast and we don't have quality, that's producing waste. That's going to be scrap, defects, rework. So we want to reduce muda and build in quality, and only produce quality at the rate that we're capable of. And then the use of stable, repeatable methods for consistency that are documented. This means we all understand. And we don't reinvent the wheel and tamper around with things. And then question technology before adoption. It doesn't say don't take technology, it says just be careful. which would create muda of things sitting around due to interrupting even flow. Because you see right here, we have a big bottleneck. So there we go. The Toyota way, the right process will produce the right results.